previous lecture we were looking at the crossbar and how the cross points are operated. So, if you remember, then I had actually drawn a state diagram there by which we can build up a control circuitry for a cross point. So, let us look at that and see how we can design a cross point circuitry. Of course, it is a very trivial exercise, but we will still do it. So, the state diagram was something like this. So, there was an off state when the cross point should not be operated, or in fact it will always remain in cross point is off and on state. I am using another state called intermediate state only to ensure that R goes first and then the row actually goes first and then the column is activated, so that it goes into on state. If the column goes first and row goes second, then it will not go into on state. So, that is the reason why we actually have also an intermediate state, and we also have an on state, and you can actually map or compare this figure what I had drawn in the earlier one. So, in fact this is RC, the row and column control, which is will lead to this state is 0 0, 0 1 and 1 1. It will go into the intermediate state if the row is activated, column is not, then only it can go into intermediate state, and it can only go to on state only via intermediate 1. Okay. And of course, if when it is in the intermediate state, if R goes back to 0, so you have 0 0 or 1 0 directly moves to 0 1, in that case it will come back to the off state. It can only go to on state when after this the column also goes up, and of course after this even if row actually becomes 0, it will remain in the same state, the column has to be maintained as 1. And of course, if you have 1 0, basically the row is activated, you will come back to again the intermediate 1, and for all other combinations, so 0 1 and 1 1 you will retain here, and if you have a 0 0 you will come back to this particular state. Okay. So, with this actually now we can build up a logic circuit. I am going to do it with a toggle flip flop, you can actually use anything else. So, since there are 3 states, I require at least 2 flip flops, so that I can each flip flop can possibly represent 2 states. So, I need to have 4 at least to represent these 3 ones, the 4th state I will not be using. Okay. So, I will be using 2 flip flops, I will draw the diagram picture here itself. I call it T1, I call it T0, Q0 and Q1, these are the outputs. In fact, there will be inverted output also which will be coming, this can be used by us. And of course, I will take these state outputs, and based on that I will decide whether I am going to actually activate the cross point or not. So, cross point is structure something like this, I had drawn it earlier also. This is one, so I am actually going to take and short these 2, and this is my activation, I call it signal P. Whenever P is high, this cross point is active, when P is low, it is not going to be active. So, I am going to generate a P from here, and the way I can represent it is that this intermediate state is represented as 1 0, on is 0 1. You can do it other way around, then the whole computation actually will change, and I can put it as 0 0, which is the off state. There is no 1 1 state of course in this case, so that will never be happening in this system. Okay. So, I have to generate this P. So, P should be only activated when you are in on state, which actually means your Q1 has to be 0 and Q0 has to be 1. So, only in that case this is what is going to be the controlling the P. So, this will only be 1 when Q1 is 0 and Q0 is 1, rest all the time it will be 0, and that is what I want here. So, it is if it is in on state, this will remain on, otherwise this cross point will not be on if you are not in the on state. So, all other states are immaterial. So, whether it is 0 0 1 0 1 1 does not matter. Of course, 1 1 will never be happening, and of course now I can actually build up. I need to just estimate what will be toggle values depending on what is the current state of these flip flops and what is my input. So, I can actually draw a Carnot map for this. It is actually elementary, but let us do it. So, I am assuming that you know that how the Carnot map operates. So, let us see if it is you are in 0 0 state. So, Q1 and Q0 both are 0 0, that is 0 state means you are in off. So, if your RC is 0 0, you come back to off state, okay. From off you come back to the off state. So, what does it mean? That from off you are coming back to off state. So, you are in 0 0 state, you are in 0 0 state, so there should not be any toggling. So, all toggle T1 and T0 both have to be 0 0. So, I require 2 of them. So, one is for T1, other one is for T0. So, I have to put a 0 here, 0 because there is no toggling required, okay. When it is 0 1, then also no toggling is required. So, here I have to put a 0. When it is 1 1, no toggling is required, so I have to put a 0 here, okay. And when it is 1 0, then it should go from off to intermediate state, okay. So, Q1 has to be toggled. So, it is 0 0, RC is 1 0. So, it has to go from 0 0 to 1 0 state, which means this has to be toggled and this should not be toggled, okay. So, once you are, this basically means I have taken care of when you were in 0 0 state. So, what will be the next state, that I have decided. There is no 1 1 state, so that becomes a do not care condition. So, I can use it for optimizing my basically logic circuit here, the commutator logic which I will be using here as an input to generate inputs to these flip flops. So, if you are in 0 1 state, in that case sorry, you are in 1 0 state, which is intermediate one. So, if you are in 1 0 state, you get a 0 0, then what is going to happen? So, I am talking about this particular row. So, 1 0, with a 0 0 you have to go to off state, which actually means only the Q1 has to be toggled. So, this will be toggled and this will not be toggled, okay. And if you are going to have a 0 1 as an input in 1 0 state, then also the same result. So, I am going to put a 1 here and a 0 here, okay. Now, if you put a 1 0 is being inputted, then what is going to happen? So, if you are in this same state, put 1 0, you go back to the same one. So, no toggling will be required. So, it has to be 0 0. and if it is 1 1, you go from 1 0 to 0 1. So, both of them have to be toggled. So, I will put a 1 here and a 1 here. Now, if you are in on state, what is going to happen? You are in state 0 1. If your RC is going to be 0 0, okay, basically these. So, it goes from 0 1 state to 0 0. So, Q1 is not toggled, but Q0 is toggled. So, Q0 is toggled, Q1 is not toggled. Then if you are in get a 0 1, you remain in same state, so no toggling. So, both of them will remain 0 0. When you get a 1 0, then you go to 1 0 state. So, both of them have to be toggled. So, this is what is going to happen, and when you have 1 1, you remain in the same state, so no toggling. So, this is what will be your Carnot map, and of course, now you can do the optimization. So, in this case, you will have this, there will be 3 terms, and of course, if you solve for this, you should get T1 should be equal to RCQ bar plus Q1 R bar. This actually term corresponds to this value, and then you will have Q1 C. So, there are 1, 2 and 3 terms. So, T1 will be given by this, and similarly from here I can find out what will be T0. So, this requires only 2 terms. So, one is combination of this, another one is this combination. So, this should be Q0 C bar plus Q1 RC. So, essentially you will take Q1 Q0, you will take R and C row and column controls, you take these as the inputs and you will take this as the input, and you will implement the logics which are here and will generate T1 and you will also generate T0. So, these the 2 logics will be implemented, these ones will be implemented in this box, and you got your controller for a cross point. Okay, and that is how your crossbar is going to be implemented.